Okay, so let's do just one final example. This is maybe not the most fun example, but it's sort of one of the prototypical. It's a good source of different sorts of possibilities. So let's go do this. License plates. Exciting. Okay, but what about license plates? Let's suppose that we're in some sort of state where the license plates are 3 letters followed by 3 digits. So we can ask sorts of various questions about, what sorts of license plates, what sorts of are possible. So the first question we can ask is, well, how many total possibilities are there? And how can I figure this out? Well, I've got 6 choices. First, I'm choosing one letter, and then my second choice is some other letter. My third choice is some other letter. My fourth choice is some digit. My fifth choice is another digit. And my sixth choice is another digit. Now, how many letters do I have to work with? 26. So N1, N2, and N3 are all 26. N4, there are 10 digits. And so N5 and N6 are also 10 digits. And so the total number of possibilities is going to be 26 times 26 times 26 times 10 times 10 times 10. And what does this work out to? It's 26 times 10 cubed. This gives the nice big number of 1. I believe that's 17 million maybe. 576,000. Okay, that's quite a few. This is enough license plates for, a moderate-sized state, or a decently big state, actually. Um, not enough for New York State, I don't think. Certainly not enough for Texas or California. But, New Jersey, whatever. A lot of states are less populous than that, so great. But what if we wanted to put some more stipulations on this? How about a similar thing to what we've already done? Let's say that there are no repeats. Now my choices are more or less the same. I've got a letter for C1. For C2, my letter can be anything but not C1. My third choice can be any letter, but it can't be C1 and C2. Now C4 is a digit, so I don't have to worry about repeating, but C5 is another digit, and it can't be equal to C4. And C6 is going to be another digit, but it cannot be equal to C5 and C4 because those have already been used. Now, how many possibilities is this? How much I could undo that? For some reason, this program doesn't do undo. I've got 26 choices for my first letter. Since my second letter can be anything but the first, it's 25 choices. And since my third letter can be anything but the first two, it's got only 24 choices. When I get to digits, I still have 10 for the first one. But for the second one, I've got one fewer digit to work with. It's 9. And for this, the third digit, the sixth choice, I can be anything but the first 2 digits chosen. So I've got 8 possibilities. So the total number of possibilities here is going to be 26 times 25 times 24 times 10 times 9 times 8. And this will work out to, my mathematical mind is telling me that is equal to 11,232,000. That's still pretty big. That only excludes so many. I would like us to just notice these sorts of patterns right here, these numbers, which is 26 times 25 times 24, 10 times 9 times 8. We're going to be seeing numbers like this a lot, where we multiply we start with a number and then multiply it by the next couple of numbers that are less than it, or maybe even more. Anyways, one final example, let's do something with no consecutive repeats. So let's just make sure that we understand what this means. So when I say consecutive, I just mean that no two letters next to each other, no two digits next to each other can be the same. So that means that ABA 010 is totally cool. That could be your license plate. But something like AAB 001 would be not cool because I've got two zeros next to each other, or I've got two A's next to each other. Okay, so then what are our possibilities? C1 can be any letter. My second choice can be any letter except for C1. My third choice, this is what's different here, is that it can be any letter except for C2. It can be the same as C1, like over here, but it can't be equal to C2. Similarly with my digits, the first guy could be any digit. The second digit could be any digit except for C4. And the sixth guy can be, this sixth character, the third digit, could be any digit except for C5. It could be equal to C4, but it can't be equal to C5. Okay, so this is bad, this is bad, this is good. Now, how many possibilities do I have for each of these? For my first letter, I have 26 possibilities. For my second letter, I can be anybody but the first guy, so I have 25 possibilities. And similarly, for my third letter, I can be anybody but the guy immediately previous, so I also have 25 choices. The same idea works for the digits. There are 10 possible digits for the first guy. I don't have to worry about repeats between digits and numbers because, well, they're different things. The fifth the number of choices for the fifth character, which is the third digit, is 9 because it could be anything but the first digit, and N6, which is the number of possibilities for my third digit, I could be equal to the first digit, but I cannot be equal to the second digit, so I can be anything but the second digit. I've got 9 possibilities. So the total number here, how much do I have? 26 times 25 times 25 times 10 times 9 times 9, and that number happens to be equal to, let me just do this, 26 times 25 times 25 times 10 times 9 times 9, that's equal to 13,162,500. Now, if you remember what the original number was, the original number of license plates was something like 17.8 million, I don't remember. And if I just stipulate that you can't have a repeated character, we only lose about 4 million plates. So if you're a small enough state, which is most states, I believe, have populations under 13 million, you could easily stipulate that your license plates look like this, assuming that the number of cars is about the same thing as the number of people. So, why would you want license plates like this? Maybe it's harder for people to remember things that are like, AAA 111, something like that. Actually, I suppose that's pretty easy to remember, but, I don't know, maybe it's easier to read if you don't have the same characters next to each other or something like that. I don't know. But, yeah, that's pretty much for this example. Yay.